Hello 8th grade, Mrs. Wagner. We want to wrap up Mod 6. This is our MGSA number 1 through 48. Okay, this is video part 1. We're going to do 1 through 12 on this one. So here we go. Number 1, I included a note on this. We did a review of this inside the videos for the actual lessons, but let's go over it again, okay? So a two-way table is used to summarize data on two categorical variables in which the rows correspond to the possible categories of one variable and the columns correspond to the possible categories of the other variable. Okay, so in this case, the variable that represents the rows is an opinion and the columns are commercial viewed, okay? And the opinion is likely to buy, unsure or likely to buy, and the commercial viewed is version 1, 2, and 3. Okay, so again, this could be, for a product of some sort. It could be for any kind of sales item, and version 1 is their actual full-length commercial. Version 2, they cut some piece out or added some piece. Version 3, the same thing, but a little bit different. Both version 2 and version 3 would be different from version 1. And then likely to buy it, how were you affected by the commercials? Which one would, help you buy it more? Okay, and then we have unsure or unlikely to buy. Okay, just to make sure you understand, the rows total up on the right side. We have a total there. Okay, they add up or sum up, and so do the columns. They sum up to a total at the bottom. Okay, and then going across this row, we have a total sum there and the columns, and notice that they both total to that 180. Okay, so let's actually try this using a two-way table. The Ecology Club was planning to take a field trip either to the seacoast or the mountains. The club president surveyed all the members to determine the preferred trip. The results are displayed in the table below. Okay, so let's look at our data here. We've got our field trip study, okay? We have the choices between seacoast or the mountains, and we have the category 7th grade and 8th grade, okay? And you can see the totals in the row and totals in the columns, and then overall total of number of students that were surveyed. Okay, so which statement is true about the results of the survey? It says A, 37.5% of 8th grade students preferred the seacoast. Okay, so we're going to go to 8th grade and we're going to go to seacoast, and we have 30 students. Okay, 30 students. So I've got 30 students. These are 8th graders. Okay, 30 out of 80 because there's a total of 80 8th graders. Okay, and then I multiply that by 100 to get the percent. All right, so when I type this into my calculator, 30 divided by 80 times 100, I get 37.5%. 37.5%. And that is the answer. That is the correct answer. A is an apple. I just want to go over how they did this for the rest of them, just so that you see how a two-way table operates. Okay, so 14% of 7th grade students preferred the mountains. Go to 7th grade and go to mountains. We have 28 out of 70. Okay, 28 out of 70. And then we have to do the times 100 to get the percent. So 28 divided by 70 times 100, and we get 40%. And they said 14, so there was no way that that could be correct. Okay, choice C was 19% of the students preferred mountains. Okay, so now we're going to mountains, and we want all of them, so that's 78 out of 150. So 78 out of 150 times 100. So we got 78 divided by 150 times 100. And we got 52%. And they said 19%, so that's definitely not it. Okay? And our last one is 52% of the students preferred the Seacoast. So we go to Seacoast. We have 72 students out of a total of 150. And then multiply that ratio by 100. So 72 divided by 150 times 100, and we get 48%. 48%. So they said 52, definitely not. Definitely not it. Okay, so there's question 1. Questions 2 and 3 are your questions to complete. They're circled, and they're just like number 1. Let's go to number 4. A crane is lowering a concrete block from the height of 175 feet above the ground at a constant rate of 4.25 feet per second. Which function can be used to determine h, the height in feet above the ground of the concrete block after s seconds? Okay, so time is always our independent variable, okay? So in y equals mx plus b, this is what they're asking for, okay? Which function? That's a linear equation, okay? So in this case, my m stays the same, my b stays the same, but x becomes s, and my y, which is the height here, becomes h, okay? Let's go over a couple of things from there. The crane is lowering. So that means it's going down. It's going down, all right? It starts from, okay, a height of 175 feet above the ground, okay? The constant rate is 4.25 feet per second. And they want the function, okay? They want the function. So what do I need to do? Well, they started from a height of 175 feet. So this is my B, okay? They started at there. When I see constant rate, I know that that's my M. But because it's going down, okay, it's declining, they want to determine the height. So if I started at 175 and I'm going down, that means my constant rate is negative, so negative 4.25. All right, so we're ready. This is my M, this is my B, that's all I needed. So H equals negative 4.25 S plus 175. Okay, so there's my function. Looking at this, oh, okay, they wrote it differently. They wrote it in the answer choices, they put the B first and then the MS. So let's just switch it. H is equal to 175 minus, I took the 175, put it to the front, okay? And then the negative 4.25S is minus 4.25S. Okay, so let's see. Oh, it's A as an apple. It's the first one. Beautiful. That worked out nicely. Okay, use these notes, number 4, to do 5 and 6. All right, number 7. A line of best fit is drawn with the goal of getting the same or close to the same amount of points above and below the line. Okay, so this is a note that I'm giving you here just to talk about line of best fit, okay? Line of best fit, or trend line, is a straight line that best represents the data on a scatter plot. This line may pass through some of the points, none of the points, or all of the points. Okay, so in the diagram here, the line of best fit is here, and you can see the scatter plot. And what I notice is it goes through several of the points of the scatter plot, and we have about the same amount of points above and below, and those points are pretty close to that line. Okay, so that's an ideal representation of the data, okay, that line of best fit. So here we go. Line K is the line is the line of best fit for a set of data on a scatter plot. The data shows a strong linear association. Which scatter plot best represents these data on and line K? Okay, so let's look at A. We've got our line of best fit. It's going through several of the points. We have several points above and below the line, and they're pretty close to it. So A is a possibility. We do have to look at all of them because it's asking us for the best representation, okay? So they may look good, but there might be another one that looks better, okay? So A is definitely possible. B, we have a line of best fit. None of there's maybe one that's touching the line, but none are actually going through it, okay? But we do have a nice number above and below the line, so B is definitely a possibility. I'm not sure about how close they are. They're a little further away than I'd like them to be, okay? So B is still in the running as well. C, line of best fit. All of the points are above that line, That's not a line of best fit. It would have had to go somewhere in between those points, so C is not possible. Okay, D came out very light. I can tell you that this is the line of best fit, and we have several points scattered all over above and below the line. However, they are very far apart from that line, and none of them are actually going through that line. So D is not a good representation for a line of best fit. All right, so it's between A and B. Well, A, the points were closer to the line than they were in B, so A is the best representation for the line of best fit on the data of a scatter plot, of this scatter plot. Okay, so using that information from number 7, you will answer questions 8 and 9. 8 and 9. So yours are circled. I'm just circling mine. All right, last one. Number 10, a company performed power tests on a set of batteries of the same type. The company determined that the equation y equals 100 minus 8.9x, where x is the number of hours of use and y is the percent of the battery power remaining, models the battery life. Based on the equation, what is the best prediction of the percent of remaining power for a battery after 6 hours? Okay, so we've got an equation. Y equals 100 minus 8.9x, okay? X is the number of hours. Y is the battery life that's remaining, okay? Remaining battery life. And they want us to come up with the best prediction for the percent of remaining power. So this is what they're looking for Y. Okay, they're looking for Y. What is Y? So Y equals, we're looking for the Y, and they told us after 6 hours. Okay, after 6 hours. So what am I going to do? Well, Y equals 100 minus 8.9x, and x is the time in hours. So Y equals 100 minus 8.9 times 6. Number of hours is 6. I can type that into my calculator exactly like that. So 100 minus 8.9 times 6, and I get 46.6, and that would be a percent, 46.6, and that is C as in cat, 46.6%. All right. That is the last question for part 1. You're going to use what we did in number 10 to answer questions 11 and 12. I will see you on the next video, on the part 2 video. We will do numbers 13 through 24. Okay, you take care, stay safe. See you in the next video.